Okay, this is like the curve we get for the our nozzle. Okay, this is a picture of that nozzle here. Okay, two
Oh,
references from NASA, and we have taken the equation that is shown here. We provided we created the internal profile with the equation, outer profile with the angle and other dimension. This will discuss in the video in the previous video. Okay, for today's video, but I took class like at the 7 p.m. Okay. Okay. Now, try to understand this thing very carefully. That I want to make the like a domain also around this geometry. The domain shape is shown already in the NASA website. That is like a similar to this one. Okay, this one, this one. Okay, so what they said is that this is like a okay. Let me go through these references. This reference, this one. So we are referring to this geometry. Okay, ARN2. All right. Okay, so in the first reference is this one. This contains like a main reference here, and it has all the data. Now, if you want to compare your data, for example, what they have is that they have the x by dz. Okay, dz is 2 inches, and x is location after the exit of nozzle on the center line. And here we have the u divided by the uz. Okay. So UZ will be equal to how much? That is equal, we can calculate that value. I have calculated that value. And we divide that one with the velocity by the UZ. This is maximum velocity we are getting there. Okay. So definitely the maximum velocity ratio will be equal to 1 then. So at what distance we are like losing the data like from here onwards. And finally it is reaching around the 30% of the total velocity of the jet. Okay. That we are going to draw along the center line. Okay. But let's make the geometry first. Okay. Okay. The domain size is very important here. So where this domain size is given, this is given here. Okay. So you can see the nozzle radius is 1 meter, 1 inch, and the nozzle is starting from the zero. That's the blue color, and it ending at the 80 inches. In the height wise, the domain is extending beyond this line. And how much this line is going to be? If this is like a 0, this is going to be the like 5, this is going to be 10. So this is equal to the 5, 10, and half value. So 12.5, something like a 12.5 will be here, okay, on this location. And on the top side, it's a 50 inches. And on this other side, this is the outer, this is equal to the 60 inches. So be careful about this thing that the distance up to here, this distance like in the red color is up to the 12.5. So that I am going to draw there. Okay. 12.5 from the origin. Okay. So let's make it. So I will be like before that, what I want is that I have the like now this line with me. Okay. This line is here. So in this line, what I'm going to draw is that I'm going to draw the few lines here. Okay. So go to sketching mode. One vertical line here as well. Okay, join these 2 points. And take this point like a backward. How much we will decide, okay? And now you can go to the modify menu, and from here you can trim this line over here. We don't need this line actually. So what we are drawing the shape of the domain right now. Okay. Okay. So Then draw the lines vertically and horizontally. Okay, this will be the like outer extent, like on the outside up to the pressure outlet. This is going to be the top domain, that is like 50 inches and the 60 inches on the two sides. We draw the inclined domain here and then from here to here. Okay. You can go to modify and trim the extra part from there. Simple. Okay, now display the axis. So we have to refer the dimensions from from the y-axis. Okay, vertical horizontal dimension from the y-axis and horizontal dimensions from the. Okay, this is the. Okay, this one. This should be equal to how much? 80 inches. Okay, how much? 80 inches. And the vertical one is like it's like a two-sided. So one point, this point, and the second point is this one. Okay, this should be equal to how much? This is a 50, and this one is a 60. Okay, now this line I told you this is equal to the 12.5. Okay, 12.5. This is equal to 12.5. Okay, now click on generate and hide the plane. Okay, now what you have to do is that you have to make another plane. Okay, so again X5 plane and make a new plane here and click on generate. So you can refer to the previous lecture why I'm creating new plane here. Okay, and right click here and insert a sketch projection of this line. Click on apply and click on generate. Okay, so now you can suppress this body and you can hide the different planes. Okay, right click here and hide plane, and in a similar way hide plane. Okay, so sketch is here. Okay, now we can directly make the domain from this sketch. Very easy. So I will go to concept menu and surfaces from sketches. Okay, this sketch, click on apply and click on generate. Okay, 1 minute. Okay, sorry. This line is not acceptable here. This line should be deleted. Okay, there should be no intermediate curve that can close the geometry in the middle region. Okay, and now click on generate. Okay, any questions, Arshad? This is clear?
Okay.
Okay. Okay, now what we have to do is that we have to like now separate this geometry into multiple parts. Why multiple parts? Because I have to create the hexa meshing same as the meshing we see here. So one division is this one, second division is this one, and third division is this one. Okay, this is clear. One division is this one, second is this one, and third one is the this one here. Okay, all right. So I'm going to have the one division here from where to where? From this point onwards. Okay. So make another curve there, where? But it's the new plane. Okay, new plane is here. So I'm going to make a new sketch. sketch number 4, go to sketching mode and draw the lines like this. Okay, no problem. Uh, I will draw the one line here and the one line on the top side. Okay. Now go to modeling tab and from here, sketch number 4 and concept menu and lines from sketches. Okay, make it add frozen and click on generate. So now we have these lines. Okay. So I will be splitting the surface into the multiple parts here. So I will go to the first split command, select the face, and my tools are going to be these lines. So I will select the curves here and select these lines here. Okay, simple. Apply and click on generate. Okay. Now just check that how many surfaces we have. This, and this. Okay. So sorry. This division should not be there. So I will delete this curve here. This curve will be deleted. Okay. So I'm going to delete this curve there. So this curve is over. I think you can keep this curve there because this will help us to make the meshing, but you can also delete that one. So go to sketching mode and click on the modify and then trim. Okay, click on generate. Now we have the three surfaces. One is here. Okay, so face split. One, two, and then the three. Okay. Okay, one thing that I want to make sure is that I want to merge the two edges, these edges are here, this and this edge, and I want to make it as a one edge. Okay, so apply and click on generate. Okay, this is now single edge is here. Okay, this one also single edge, and this is the two separate edges because they are two different domains, but we can join them into the one boundary condition. Okay. Now we have to put the boundary condition names here. Okay. So you can suppress these line boundaries, but line bodies, and that's all. Okay. So we have now three surfaces, 1, 2, and 3. Okay. So now define the boundary conditions. So one is going to be the axis boundary condition that is here. Right click here, name selection, and this is the axis. So click on generate. This is going to be the outlet. And this is going to be the also this is I would call this one as a symmetry. Okay. And this is the free stream inlet. Okay. This is inlet, but free stream inlet. This is like representing the free stream domain there. So this is the inlet, but this is going to be the free stream. Okay. This is going to be the nozzle, outside nozzle area. So name selection. This is the wall, nozzle, outside. Okay. Click on generate. And this one is going to be the nozzle wall, but on the inlet side. Okay. Okay, so we have the symmetry condition on the top. outer is here. We have the axis on the bottom side, symmetry here, inlet free domain, free stream domain here, wall, outer nozzle is here. Last boundary condition is the nozzle inlet. Okay, so this is the inlet of the nozzle. This is the inlet nozzle. Okay, save the file. That's all. Okay, now we will go to the like a meshing software. So double click on the mesh. And by the way, the mesh which I created is looks like in this way. It is like a slightly different mesh, like it's a fine mesh here as well. This is the mesh I created last time, okay, for the course. Okay, Arshad, can you see the screen? This is geometry with us, okay? Okay, one thing you should make sure that the geometry should have the dimensions of the 2D. Okay, so it's a 3D here. So just make sure this is the 2D actually.
Yes, this is 2D.
Yes, so make it 2D. And double click again, double click on the geometry meshing and reread the new geometry.